All right, welcome. Today we are talking about proving triangles congruent. So we already talked about properties of congruent triangles. Today we are going to look at ways that we can prove two triangles are congruent if that fact is not given to us. We're going to look at two different postulates. The first is the side-side-side postulate. And the second is the side-angle-side postulate. Side-side-side I feel like is the most straightforward. Basically tells us that if you have two triangles where each of the corresponding sides are congruent to that of the other triangle, then you have to have congruent triangles. In other words, if I have two triangles with the exact same set of side lengths, then they have to be congruent. I feel like that's mostly common sense. Otherwise, there's no way that you could make them congruent, right? If all three sides match, the angles are going to have to match, or else everything's not going to line up the way we want it to. Side-angle side tells us that if we have two sets of matching sides, and we know that the angle in between them matches in both triangles, then the triangles must be congruent. Not much else to say there. Basically, when you're looking at your picture, you just need to watch for the positions of the marked sides and angles. If the angle is in between, then we know we're dealing with side angle side. So let's look at how this is going to play out in an example. So we are given a picture. We've got two triangles highlighted for us, and we want to prove that triangle WXZ is congruent to the triangle YZX. So, how are we going to do this? Well, let's pay attention to what we were given. So first of all, we are given that WX is congruent to YZ. If we look at our picture, see WX is up here, YZ is down here, so it looks like we've got at least one pair of congruent sides. We are also given that WX is parallel to ZY. So that's not giving us anything congruent just yet, but we are moving closer to where we want to be. Remember, we either need to know that all three sets of sides match, or we need to know that an angle between two sides matches. I look at it, we've got one set of matching sides already. Notice that XZ is in both triangles. So we've got a second pair, or we've got a second matching side right there. Now we need either to get an angle that matches, or we need to prove that the third side of the triangle matches the third side of the other triangle. Since we were given parallel lines, and we learned all those rules about parallel lines forming congruent angles, it's going to be easier to deal with the angle. So I look at this, I notice, okay, I've got some alternate interior angles there, and we know that with parallel lines, our alternate interior angles must be congruent. So that's how we are going to get where we want to go. So we said that we were given the congruent sides and the parallel lines. The next thing we said was that XZ is in both triangles, so XZ is congruent to itself. Remember, we call that the reflexive property. We know that angle WXZ is congruent to angle YZX. And we said those are alternate interior angles. The fact that they're congruent is based off of our alternate interior angles theorem. And so now we've got two sets of parallel or congruent sides, and we've got the angle in between them, so we are ready to write down the proof statement. So we know that triangle WXZ is congruent to triangle YZX using the side angle side postulate, which we can shorten to SAS. So let's go ahead and go through and just add in some geometric symbols to make this look nicer. All right, so these were lines. So we need little lines. So notice I'm putting a little triangle in front of the triangles and angle symbol in front of the angles so that we don't get mixed up when we are reading back over this. All right, that is our proof. I will go ahead and let you try the next one. You want to kind of set it up the same way. Just look for your congruent sides and your congruent angles. All right, so example 2. This one's a little bit different. So we are looking to prove that CFD is congruent to CEB. Now, there's two different ways we can get to this. One of them involves isosceles triangles and another involves congruent triangles. I'm going to do the method with congruent triangles because I want to show you guys how that works. So just like before, we're going to start with our given statement. For the sake of time, I'm just going to type it out as given, and then I'll draw a little arrow in a minute to put it where it needs to be. So using our given statement, you notice we have two sets of matching sides and the angle in between them already marked. So we can say that triangle CBF is congruent to triangle CDE using our side angle side postulate. If the two triangles are congruent, then we said that the corresponding angles have to be congruent as well, right? So since both B, or sorry, we don't want to use B, we want to say, since F and E are both in the same position in our congruent statement, we know those two angles have to match. So what we're going to say is that angle CFB is congruent to angle CED because corresponding parts of congruent triangles are congruent. Again, that's corresponding parts of congruent triangles are congruent. All right, so the next thing we want to say. We know that angles BFC and CFD are supplementary. We also know that angles DEC and C, E, B are supplementary. And this is because they are linear pairs. So this is going to be the linear pair theorem. And then the last thing we need to say, angle CFD is congruent to angle CEB, because both of those angles are supplementary to a pair of congruent angles. So this is our congruent supplements theorem. All right, so let's just clean this up a little bit. Add in our geometric symbols. And we will be good to go. So let's see, these were triangles. See, these were angles. Angle, 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 angle. And there's our proof. All right, that's all I have for today. I will see you next time.